Hi everyone, today I'll be showing you how to solve number 34 on page 76 for chapter 3 physics homework. So 34 is about the person who kicks the rock off the cliff, and I'm sure you could read the problem, but first we want to draw our diagram. So my diagram looks like this. You have the person kicking the rock off of the cliff into the water. This is the height of the cliff, 40 meters, and you're trying to solve for initial velocity. And also another component which is worth mentioning is that it says that the rock is kicked horizontally, which means the initial velocity is only horizontal, which is why you're solving for the horizontal component of the initial velocity. So the rest of the problem talks about how the sound, the person who kicks the rock hears the sound 3 seconds after he kicks the rock, and I want to show you guys this equation that I made for myself. So you have the speed of sound, which is 343 meters per second, and you have the total time, which is 3 seconds, is equal to time that it takes for the rock to fall into the water, plus the time that it takes for the rock to travel back up. So this is the full thing. 3 seconds is equal to the time it takes for the rock to fall, plus the time that it takes for the sound to travel back up through the same path, back up to the people. So that is more of a straight line diagonally. We'll get to that later in the problem. Now we want to write out all of our givens in a table. So these are my givens, and we aren't given much, but we're giving enough. So since it says that the rock is kicked horizontally, that means that the initial speed of the rock, there is no y component since the person kicks it only horizontally, which means the initial speed for y is 0. We have the change in y, which is basically the height of the cliff, which is 40 meters, and the acceleration due to gravity, which is 9.8 meters per second squared. Having these three components, we can find the time. So I'm going to explain to you the plan I have for this problem. We can find the time, and since the time is the same for x and y, we can put it over here. We can find the change in x, and then we can easily solve for velocity initial because it is the same as velocity final since speed in the x direction is constant throughout the time. So this is a little diagram I drew myself so that when we're finding the change in x. So we actually have a right triangle since the sound, when it's coming back, it comes back to a straight line to this person who kicks the rock. We have the vertical component, which is 40 meters because that was given to us, the height of the cliff, and we have, well actually we don't, sorry. We're trying to find this change of x, which is horizontal, but for that we need to find this one, which is the hypotenuse. So let's first start with the easier component. Let's find time. Since we are given 3 parts, we can find it. So I drew time in green, or I wrote it. So we have our initial velocity in the y direction, 0, times t plus 1/2 times acceleration due to gravity times t squared equals the height, 40 meters. And we get the time is about 2.86 seconds. Now, this is the time it takes for the rock to fall into the water. So now we have another component of the equation I showed you in the beginning. And we get 3 seconds is equal to 2.86 seconds plus time that it takes for the sound to travel back up. 2.86 seconds is the time it takes for the rock to fall into the water. And we want to find t travel because we are given the speed of sound, and we know that sound has to travel back the change in x, the same change in x that I drew on this diagram. This is the distance sound has to travel back up to the spectator, except in the different direction since he's going back up to the person who kicked the rock. And we have time travel now, since 3 minus 2.86 seconds gives you the time it takes for the sound to travel back up to the person who kicked the rock, which is 0.14 seconds. Now, using that information, we can find the change in x, which is the hypotenuse of a right triangle, right? Since sound does have to travel back up to the person who kicked the rock, we take the speed of sound, which is 343, multiply it by 0.14 seconds, because acceleration doesn't act on sound because it's not a physical object. We just use the d equals rt, or distance equals speed times time formula, and we get that the hypotenuse of a right triangle, or the distance that sound travels back up to the spectator, and that the distance that the rock falls, is 48.02 meters. And now, let me just fix the papers. We can plug that in to our right triangle, right? We were trying to solve for the hypotenuse. We solved for that by multiplying the speed of sound times the time it takes for sound to travel back up, and now we're trying to solve for this leg of a triangle. Well, this is Pythagorean theorem, because this is a right triangle. There should be a right triangle mark here. So we solve it using Pythagorean theorem, and we get that the change in the x direction, which is basically the distance the rock travels in the x direction, is 26.7 meters. Well, aren't we trying to find velocity initial in the x direction? And we have three components. We have acceleration, time, 2.86 seconds, which is the total time it takes for the rock to fall. We have the distance, which we found here. It's 26.57. So we just plug that into one of our kinematic equations. So we have change in x is equal to VIT plus 1/2 AT squared. When we plug everything in, we get 26.57 meters is equal to VI times 2.86 seconds. This we don't have to count because the acceleration is 0, so this whole term cancels out because you multiply by 0. And you get velocity initial is equal to 9.29 meters per second. And that is your answer, because since in the problem it says that the rock is kicked with a horizontal initial velocity, we found out that the vertical initial velocity is 0 meters per second, which means that all we're trying to find is the horizontal component without any vertical component. And we found it. That is the horizontal component of the initial velocity, which is the only component of initial velocity. It's 9.29 meters per second. Thank you for watching. I hope this helps. Bye.